Hey guys, this is Mr. Myesis, and I'd like to go over with you some things that I went over in class today for the next test in AP Stats. This is for Unit 7, and that is on inference for means. And in my course, everything is cumulative. So this is actually a cumulative exam from the entire year to Unit 7. So I will post this up on YouTube, although, really it's more for my students and my colleague students for what they need to know to study for the exam. However, if you do want to stick on here and you're on my YouTube channel, you can just kind of stick on with what I'm going to be talking about, and I will be going over some examples, some items that you want to think about when you're looking at a test, an exam on inference for proportions and inference for means, inference in general, and then just kind of a review of some of the topics that we're going to be looking at in AP Statistics. Now, again, this is very focused on my students or my colleague students and what's going to be on this particular exam. So I'd like to go over with you what's going to be on this particular exam. I am also going to go over some review problems. So just really quickly, I'm going to give you the answers, and then I made some notes on there so you can take and pause this video when you see a problem that you want to take a look at the notes and write these down, okay? I'll post this also up on Google Classroom so every student can take a look at it. All right, so let's start here. So I am going to first start with these review problems. It says Unit 6, but it's actually Unit 7 in my course, and we're talking about inference for means. So let's start here, and then after that, I'm going to go over what's going to be on the exam, what are the topics that you're going to want to study, and hopefully this video won't be too long. I want to try to make it as short as possible because I have a lot of stuff to do too. So here we go. Let's take a look at the review problems. So if I can move myself out of the way, here we go. So we've got number one here is B. Take a look at this problem if you want to. I'm not going to really read these out. You guys can read. So I'm just going to go talk about the reason why the answer is the answer and then kind of move on pretty quickly. So when we look, we have a significant difference. Whenever we have the word significant difference, statistically significant, we're talking about whether or not we're going to reject a null hypothesis. So if we reject a null hypothesis, then our evidence is statistically significant. If we don't, then we do not have statistically significant evidence, and we're going to fail to reject a null hypothesis. By the way, if you're one of my students, you want to listen to all these little things I talk about, because all these little things in there might show up on the exam. So whatever I'm talking about, you want to make sure you take a note of it. And I'll go over more specifics what's going to be on the exam in just a few moments here. So the reason I know this is a two-sample Z-test for proportions because we're talking about rates. Nowhere in this problem does it say anything about means. If it says mean or standard deviation, that's pretty good hint that I'm going to be using a t-test or a t-interval. All right? All right, number two was E. A Z-score is about how many standard deviations away from the mean we are, and that's, just straightforward. Number three, on my problems in my class, we had a bit of a printing error. This 8 was down here. It should actually be right here. And so all I'm going to do is go through this in a simple random sample and look and pick the ones that work for me. In this case, it's C. Sorry if those of you that are watching my video and are wanting more of an explanation for each of these problems. I'm just kind of going through some of these very quickly because some of these aren't even on our exam. Number four, now if you notice here, this picture is actually a distractor picture. This picture is about the data from the 300 basketball games, not what we're asking for. We're asking actually to describe the shape of the sampling distribution of sample means for sample sizes of n equals 30. A sampling distribution is going to be approximately normally distributed if we pass those three conditions. The three conditions were 1, random sample. We have it. It's SRS. 2, less than 10%. 30 is, in fact, 10% of 300, so we're okay on that. And if our sample size greater than or equal to 30. In this case, it is equal to 30, so we're okay, which means our sampling distribution will be approximately normally distributed. So be careful if you're looking at a sampling distribution or a sample distribution, okay? Number 5, here's the solution for number 5. Now, I probably would have changed these values here to like something closer to the 112, but we're going to use 1.96 because we've got kind of a, we don't know how many, so we're just going to use a z-score for that one. We use the margin of error for the t interval, and this is the margin of error. We set that equal to 0.5, and we solve for n. All right, closest one here is 155. Number 6 is a GeometricCDF problem. It is important for you on this exam to understand what the difference, to be able to identify the difference between a geometric and a binomial problem, probability problem, okay? So I'll talk about that in a second. I'll go over geometric and binomial in a little bit. Actually, since I have this problem here, I might as well just talk about it now. So remember that geometric and binomial probability distributions are only happen if there are Bernoulli trials. A Bernoulli trial only happens if we know the probability of success. There's only successes and failures, and each trial is independent. And the trials can't change probabilities, right? So those are Bernoulli trials. We have geometric and binomials that go with those. We know this is a geometric because it's saying what's the probability we'll find is first Democrat by the third person. So that is geometric because we're looking for the first success on the nth trial. Whereas a binomial, we are looking to see how many successes out of a certain number of trials. Okay, so that's the difference between a geometric and a binomial. Number 7 is D. D is the actual interpretation of confidence level. So remember, if I'm asking for what does 90% confidence mean, like what does it mean to be 90% confident, I'm saying that if I took a bunch of random samples of the same sample size, that that the probability that I capture the true proportion in those confidence intervals is 90%. So if I made 100 confidence intervals, about 90 out of those hundreds should contain the true proportion. That's the interpretation of a confidence level. Number 8, it doesn't matter if you switch the variables, you're still going to get the same correlation coefficient. Number 9, make sure that you know the differences between the two. This is multi-stage because I randomized like 3 times in this one, whereas a simple random sample is just, straight numbering them and taking the random sample. There's no such thing as a survey sample. Number 10, there's the answer for that. I don't think this one was too hard. You're just looking for expected value here. So you multiply times the probability. Number 11, something to notice about number 11 is that the bottom box plot is the older rats or older mice. And since we're looking for faster times, since the box is more to the left of the other box, these are going to be faster times. We don't know how many mice in each one ran whatever. We just know that the percentages. Number 12 is a really important problem because there will be plenty of problems on the test about type 1, type 2 error, and power. So you're going to want to make sure you study type 1, type 2 error, and power. So just to review this problem very quickly, when the company tested it against a similar medication from another company with a sample size of 100 in a double-blind test, it showed no statistical difference between the two medications. So if I show no statistical difference, I talked about this before, that means that I failed to reject the null hypothesis. Okay? No statistical difference, failed to reject the null. Let's move on. When we increase the sample size, now what happens when we increase the sample size? Anytime you increase the sample size, you decrease type 1 error, you decrease type 2 error, and you increase power. So right away, with increasing the sample size, we're increasing the power of our test. What happens when we increase the sample size? Well, it said that the results showed a clear statistical difference between the new medication was more effective. So what that tells me is that with more sample size, I was able to reject the null hypothesis and say that there was there's statistically significant evidence. So what happened? With a lower sample size, I failed to reject the null when I really should have rejected it. What type of error is that? That's a type 2 error because I failed to reject the null when I really should have done the other thing. So if I did a type 2 error, and then I increased the sample size and found that I was wrong, then what happened was I had too low power. Power is the ability to not make a type 2 error. Okay, so by increasing the sample size, I increase the power. 13. Now for 13, what I would do is I would subtract these. This is a matched pairs t-test because I have the same people using the right hand and the left hand. So using the same people is a matched pairs t-test, not a two-sample t-test. If I had put these data in my calculator and I run a two-sample t-test, I would have got 0.376, which would have been the incorrect answer. I would need to do a matched pairs t-test, so I'm first going to do subtraction. I'm going to subtract and find all the differences like I did here. Then I'm going to put those differences in my spreadsheet, in my calculator, and then I'm going to run a one-sample t-test with a alternative hypothesis of not equal to, because it's just asking for a difference. So I run that test. I end up getting a p-value of 0.493. All right. Now, number 14, Venn diagram. Okay. So just make sure, look, you have to put, this has got to be a 0.1 here, not a 0.5, because 0.5 is those that order cinnamon rolls. That's the entire circle. So you actually got to subtract those out. So now you add them all together, subtract to get 20%. All right, 15. There are actually quite a few problems on this exam that look like this. The answers are not like, oh, it's just a confidence interval. All right. It's actually how it would look if you had to use the formula for the confidence interval. And they do this a lot on the AP exam. They don't give you the confidence interval because you can just put the stuff in and get the confidence interval on your calculator. But they want to know that you know how to use the formulas and that you know which one to use. So they're going to put it in this format here. All right. So make sure you recognize how to find the margin of error and the point estimate. In this case, the point estimate was 32.7. And lastly, number 16. So what you do here for 16 is that you're going to use the t-value. The t-value is your test statistic. So in your mechanics, if you're finding the z-score or the t-score, that's your test statistic. And then you're going to use, for a z, you're going to use a normal CDF. For a t, you're going to use a t-CDF. So what I did to find this is I used t-CDF in my calculator. I did a lower bound of 3.27 and an upper bound of 9.999. And then I used a degrees of freedom of 319 because I had 320 students in my sample. I did that and I found t-CDF, and this was a two-sided test. So whatever value I got for that, I had to multiply by 2. That gave me my p-value. When I checked the p-value, my p-value was in fact less than my alpha level of 0.05. So that means that there is significant evidence. So I'm looking for that word significantly or statistically significant difference. Which means that I rejected the null hypothesis. All right. So those are the problems from our multiple choice review. Again, if you're watching this video and you're not in my class, I still think this is a pretty good problems to work on for this type of unit. Okay, some practice problems. Okay. So now let's talk about. I'm going to put me full screen and let's talk about what's on the test. All right. So now, if you're one of my students or one of my colleague students, I'm going to talk about what's on the test. And you can take these down. These are just some important things that you're going to need to know. So the test is going to be multiple choice, 20 questions on multiple choice, 6 questions on free response. The multiple choice will be first. And on the free response, let me talk about the free response first, and then I'll talk about the multiple choice, even though the multiple choice is first. Okay, it's just because I have my notes written down this way. So on the free response, you're definitely going to need to be able to describe a distribution. So using CUS, center, unusual features, shape, and spread. You might need to do some more than just that. I like to some analyze. So if I ask you to provide statistical explanations, you got to make sure you use some stats and talk about it that way. You're going to need to be able to do something with linear regression and association. So probably using strength, type, and direction, and then determining a linear regression or putting the slope in, interpreting the slope. I've asked you those types of questions the past 3 or 4 exams. I'm going to continue to do that. There will be a probability question on this exam, so probably either doing expected values or doing a binomial probability or something in that vein. So I know I haven't asked you too many probability questions in the past. This time I will. There will be a question on experiments and observations. We did it in the previous one. I asked you if this was an experiment or an observational study and a confounding variable. Probably something in the same way, only this time I might ask you to design an experiment. So, or talk about bias. So probably somewhere in that vein. And then there will be an inference problem, probably something about confidence intervals, something about p-values, just something in general about inference. And then, of course, there's going to be a hypothesis test. And you're going to have to choose which one to use. Now, if I was a betting person, I'd probably say it's either going to be a T, one sample T, a matched pairs, or a two sample T test, because that's what this unit was on. But it could be anything. So just make sure you remember what I went over in terms of how do you tell the difference. Okay, so now the multiple choice, and this is kind of, some of this stuff also is just kind of general. You're going to want to make sure you understand. There are quite a few problems on the multiple choice that have to do with confidence intervals. So make sure you understand how to find a confidence interval, how to determine which confidence interval you're using. Are you doing a Z interval or a T interval? The easy way to tell is anything that says mean, you're using a T. Anything that says out of or has percentages, you're using proportions or a Z. Be able to find your T star using your T table. Going to be very important, and be able to find just like the standard error in your formula or the margin of error. I might just ask you for those pieces. So be able to interpret your confidence interval. That's a question on the exam. So a lot of stuff on confidence intervals. You'll need to find the expected value of a probability distribution. So be able to do that. Know how to decide which display to use. Like which displays do you use for categorical data? Which displays do you use for quantitative data? Which displays are better used when you have large sets of data or discrete data? So like all of these things that go on with which is the best display to use. So you're going to have to identify which of those, at least in 2 multiple choice problems. Okay, so again, I talked about, okay, so you'll have to decide in at least a couple problems which test to use. Just on the, like, I'll just give you a scenario, and you have to say, oh, I'm going to use a matched pairs t-test, or I'm going to use a 2-sample t-test, or I'm going to use a 2-prob z-test. So you just got to decide which one you're going to use. Know how to find the predicted value using a linear regression equation. Know how to find the residual value. If I give you the residual, be able to find the actual value. I'm not going to do any problems like that on this video. You should go and take a look at, like, you can watch a video on how I do that, or you can go back and take a look at some of the examples we did in previous exams and problems. I'm going to ask you several questions where I'm just going to ask you to write the hypothesis. So given a scenario, what are the null and alternative hypotheses for this problem? So make sure you understand how to do that. You can decide which one to use, and most importantly, and this is just let me just talk about inference for a second. Now, when we do inference, confidence intervals, hypothesis tests, and sampling distributions, but mostly just the other two. When we're dealing with hypothesis tests and confidence intervals, we are talking about populations. We're using a sample to make inferences on populations. So our hypotheses are always in terms of populations. That's why we use a mu, which is a parameter. That's why we use a p, which is a parameter of population proportion. We are not ever using x bars or p hats in our hypotheses, because our hypotheses are about populations. Same thing goes with confidence intervals. When I interpret a confidence interval, it's about what I believe, what I estimate the true proportion, the population proportion, or the population mean to be. All right? We're not talking about a sample. We're talking about the population. Now, we're using a sample, but we're using a sample to say something about a population. This is a very, very important foundation of what we're talking about when we talk about inference procedures. Okay? All right, know just a couple other things. Make sure you know all that linear regression stuff, residuals, how to test things are appropriate or not. Those are all going to be on the test. And then back on inference things, remember type 1, type 2 errors. I talked about this again. How does sample size affect each of these errors? How does it affect power? What does it do for your margin of error? By the way, just a pro tip on the AP exam. Sample size is usually not the answer. It's there to trick you. It's really only the answer if we're talking about type 1, type 2 error, power, or margin of error. Okay, other stuff from review materials. Make sure you know how to determine what type of sampling method. All right, cluster, stratified, SRS, things like that. Make sure you can determine if something is experiment or observational study. And then furthermore, how do you make sure that you randomize the placement of treatments onto groups? Okay, so let's talk more about inference. There's a lot of inference on this test because it's mostly inference. So, oh, one other thing I forgot to mention. Make sure you know that when you add or multiply, that changes your standard deviation and your IQR and any measure of spread. But measures of spread are not changed by just adding a number. Only measures of centers are changed by adding a number. Okay, so let's go on to the inference procedures that you're going to need to make sure you understand. Additionally, from what I've already talked about. So make sure that last thing I want to talk about is confidence intervals. So when you deal with confidence intervals, remember that the more confident you are, the wider your interval needs to get, right? Because think of the confidence interval as a target, almost like a bullseye, right? My big confidence interval, the whole target, I'm pretty confident I can hit the target. I could, not the board, right? The round board, I'm pretty confident I can hit the round board. But as that gets smaller, and my target gets smaller, think of that as my confidence interval. As my confidence interval gets smaller, my confidence level decreases as well, because I'm not as confident that I'm going to get the true proportion of the true mean within that interval. So the larger the confidence level, the larger the interval, the larger margin of error I get. Okay? It means I'm going to have less precision, but that's the price you pay. So last thing, I know this is a very long video. I've taken like 22 minutes on this guy, but I felt there was a lot of stuff to talk about. Last thing here, and I'm going to actually go to my, turn dark. Turn dark. Hold on one second. Oh, man. All right, lights back on. Sorry about that. Let me go to my document here. Okay. I'm going to start a new page here so I can show you something. Okay. So what I wanted to show you just real quick was if I had, let's suppose I had a null hypothesis of mu equals 123 and an alternative hypothesis of mu is greater than 123. And I get a 90% confidence interval, and my interval looks like this, 100 to 195. The question I have for you that you're going to need to make sure you understand is, can I make a conclusion of my hypotheses based on my confidence interval? The answer to that is yes. So the question is, what is that conclusion? Well, here's what you're going to do. If your interval, if you're one of my students, hopefully you talked about this first, but if your null hypothesis is within your interval, then it's possible that the null hypothesis is true. So if that happens, I'm going to fail to reject the null. Fail to reject the null because it's possible the null is true. Okay? Now, what if my 95% confidence interval came out to be 140 to 195? Well, the null is not in there. In fact, all of the numbers are above 123. In this case, I will reject the null hypothesis and say that there is significant evidence that the alternative is true. So I could use my confidence intervals to make conclusions of my hypotheses based on whether or not the null is within my interval. Okay? So make sure you understand that. That is very important both likely for the multiple choice and the free response. All right. So I went over a lot of information here. I spent like 25 minutes going over things. Hopefully that helps and gets you ready for the test. And again, I'm going to post this on Google Classroom as well as YouTube. Hopefully those that are just watching this because you know what, you just you're a subscriber, and hopefully it helped in any stats that you're taking. All right. See you guys later. My SS out.